Well, Unit 1, Lesson 3, Initial Value Problems. From now on, I'll refer to them as IVPs, and I hope you'll know what that means. If we have a differential equation, and this is just kind of saying any general form that's of degree n, it's a nth order differential equation, and this is just some combination of other derivatives of the function y and some value of x. And we have enough initial conditions for x sub 0, we have a value, y sub 0. In other words, if we have an nth order equation, if you think about it, that means we got n derivatives in there, and in order to find all the constants required when you integrate, you're going to have n initial conditions. And so initial conditions, we'll call that IC. Then you need to have 1, 2, up to, if you really count this correctly, that's n, because you started at 0. That's n different initial conditions, and you're going to need n because it's an nth order equation. So when you have an IVP of a DE and you want to find the constants, so then you can find a particular solution instead of the general solution, then you'll need as many IC as the order of the equation. So for an IVP, you need IC.
Are you trying to give me the double talk?
Certainly. Okay, well, anyway, here's an example of an initial value problem. Here's a differential equation, dy dx equals some function of x and y, with initial condition when x is x0, y is y0. So this is only a first order, so there's our one initial condition, which is all we need. Here's a second order equation, so we have to have two initial conditions. One of them is y of x, I should make that sub 0, this one too, y of x0 equals y sub 0, and y prime, see, y prime at x0 equals y1. So we have two initial conditions because it's a second order equation. This one, the ODE, that's ordinary differential equation, y prime equals ky, is a hugely important model and has lots of applications to real life. It says the change in something is proportional to the amount of something. And a lot of populations are like that. Newton's law of cooling is essentially that. Many things which you've probably seen by now in your studies of science and math should work like that and give you this solution. We'll talk about how to solve that in another lesson. That's actually a type called a separable equation. But that is the solution for this very important differential equation. But just having the solution isn't going to help us unless we have some way of finding the C. And here's an initial condition. When y of 0 equals -2, then we can put in -2 for y and 0 for x, and then we'll get -2 equals c times e to the k times 0. That's e to the 0, and e to the 0 everyone knows is 1. So c equals -2. And if we know that c is -2, then the solution for that differential equation is y equals -2 times e to the kt. Doesn't even matter what k is for that one. So that's kind of our initial condition. You know, a lot of times they're called initial because they happen when x equals 0, at the beginning, so to speak.